Thanks, Mark. I just want to formally welcome everybody here today, introduce the board to you and encourage you to go and say hello to all the members of the board and ask any questions you want. That's what today's about, is access for shareholders to Mark and to the board. So Joycelyn Morton, who's just joined the board recently, welcome Joycelyn, Ian Levy at the front here, and Rex Adams there, and myself. We, along with Mark, are managing this company for you, and we do very much encourage you to move around and introduce yourselves, and we will do the same. And if you see people standing in the corner and none of us board members are going over to bring them into the group, complain, because we're not doing our job. I also want to offer a very special warm welcome to our event today to Chris Pottinger from B4. He's an expert on fluorine, and he's going to give a great insight into how our project can fit into the wider industry place of aluminium fluoride and fluorine-based chemicals. So thank you very much, Chris, for making time to be part of this today, because it's a very important part of what we're about. And of course, Margarita Johnson, who's going to be joining us by video. She's from the Aluminium Council, and Mark's put us into the Aluminium Council in recent times so that we can begin to meld our way into the wider industry. So what's happening today is this morning Mark's going to take you through the Alcore strategy, where we've got to since we had the last open day, tell you more about the exciting announcement that we made to the market this morning. Great work, Chow, and your team up here, what you've done there. And then this afternoon we want to introduce you to our ionic adsorption clay rare earths project, which is extremely exciting. The discovery we've made in Tasmania, very, very significant project, and Mark will give you an introduction to that and explain to you what's happening with that project and how it's developing and what the likely developments there are with that. So without any further ado, I will welcome Mark back to the stage to get proceedings underway, and I look forward to catching up with everyone through the day. Thank you.
So, I mean, most of you, I think, are familiar with ABX, but I will describe it just to be complete. Our two very clear focus areas now are the ionic absorption clay rare earth project in northern Tasmania and the Alcore project that we're talking about today. They're independent projects, but there's logic to why we're doing them. They both spawned from our earlier bauxite work. So Alcore came first. The idea was, can we convert bauxite using some clever chemistry into aluminium fluoride, a high-value chemical? As we did that project, we realised the economics of that idea actually depend more on the fluorine rather than the aluminium out of bauxite. So we started doing more work on the fluorine, and then realised that actually is the project. So that link to bauxite now is not really there. Likewise, the rare earths. We had bauxite resources, Tasmania, New South Wales, Queensland. Ian, visionary geologist, had the idea, okay, there could be rare earths associated with this bauxite, and we deliberately started looking for rare earths and found them, and that's led to that rare earth project. Again, now that link to bauxite is largely not there. So there's very clear logic to both those projects being really attractive. You might say, oh, why do both? Pick one. Believe me, if I thought one was much better than the other, I would pick one. And I'd be saying to the board, let's just do one. They're both really attractive projects. I honestly, even myself, if someone said, if we split the company and you worked on one of them, which one would you work on, Mark? I don't know. They're both really good projects. The bauxite is still there. We're not investing in it. We don't explore for bauxite, but we have the resources, and so absolutely we're looking to mine and sell bauxite where we can. It's a way of generating cash flow into the business. But in terms of investment dollars, that's going into either Alcore or the rare earths. Paul's just described the board. I'll just leave that slide there for you to read. But certainly the board recognised that it was a good idea to bring in new expertise into the board, which is why we appointed Joycelyn to both ABX and Alcore earlier this year. And that's something we'll continue to look at, in coming years. It's obviously an important part of a small company. We've only got about 10 staff, so the board's a very important part of the company. And we think we've got a really good board that has got the breadth of experience and the appetite to be leading, a small company like ABX, but also with the vision to say, what could we become? Right? We're not just an exploration company drilling some holes. We're trying to create two really good projects. And an example of that is our increasing focus on ESG. So obviously this is becoming more topical across the society and the market. It's going to become compulsory soon for large organisations to report against ESG. That's not going to affect us directly. But in the last 12 months, we thought it was time, look, let's start getting our house in order here. Both our projects are very strong on the environment. That's why we're doing them. The Alcore is about recycling a waste into valuable products. The rare earth project is about mining and producing rare earths to enable the renewable economy. We can't do it without them. But that's only one part of ESG. So we said, right, let's partner with a reputable partner who uses a structured framework to help companies assess where they are on ESG. We just published our first baseline report last week, I think it was. It just shows here's where we are. The part of the learning I actually got out of it was some elements are not so important for us right now. We're only small, so we're not making a big impact on the environment or economics. But things like governance, like our board, are really important. And going through this process helps us realise what are the actions we can take over the next 12 months to help us make a better company. The ESG is not just a compliance thing. That's obviously one part of it. But it is genuinely about how can you be a better company in today's society. And so we're going to recognise those opportunities where we can become a better company. And so what we'll do on ESG will change over coming quarters and years, but it's something that we'll be actively working on.
Thank you, Alcore, for inviting me to your open day. I'm sorry I can't be there in person. My name is Margarita Johnston, and I am the CEO of the Australian Aluminium Council. The Council represents Australia's bauxite mining, alumina refining, aluminium smelting, and downstream processing industries. The aluminium industry in Australia has been operating since 1955 and over the decades has been a significant contributor to our nation's economy. The council members include 5 bauxite mines, which collectively produce more than 100 million tonnes per annum, making Australia one of the world's largest producers of bauxite. The 6 alumina refineries produce around 20 million tonnes of alumina, making Australia one of the world's largest export producers and the largest exporter of alumina. Australia has 4 aluminium smelters, making it the 7th largest producer of aluminium. There is also a downstream manufacturing industry, including more than 20 extrusion presses. Aluminium today is Australia's highest earning manufacturing export. Our industry employs more than 19,000 people and indirectly supports around 60,000 families, predominantly in regional Australia. The majority of these employees are in the value-adding alumina, aluminium and extrusion industries. The council's members stretch right across the value chain in Australia, from mine to market. They include the majority owners of all the major mines, refineries and smelters, including Rio Tinto, Alcore and South32. The council also represents the bauxite exploration sector, including VBX and Glencore, major joint venture partner Alumina Limited, and the downstream sector, including Capral, G. James and Vulcan, as well as Alpha High Purity Alumina. Aluminium is one of the commodities most widely used in the global transition to a clean energy future and is globally recognised as both a critical mineral and strategic material. In December last year, aluminium was added to Australia's strategic materials list. Australia is well positioned to use its existing backbone of value-adding industries in Australia to develop new industries, which will meet these future needs, reduce supply chain challenges and sovereign risk. Australia is one of the very few countries globally which has bauxite mining, alumina refining, aluminium smelting and aluminium extrusion industries. However, today, Australia does not have a domestic supply of aluminium fluoride, which is an essential for the continuous operation of our aluminium smelters. Recognising this challenge, in December last year, the Australian government added fluorine to the critical minerals list in order to help support new industries like Alcore to create diverse, resilient and sustainable supply chains, to build our sovereign capability in critical minerals processing, use our critical minerals to help Australia become a green metals and renewable energy superpower, and extract more value from our resources onshore, creating jobs and economic opportunities. The government has shown their support for critical minerals in recent funding announcements, such as that for Alpha HPA, another critical mineral closely aligned with the aluminium industry. Through Alcore, the potential to establish a domestic aluminium fluorine production industry would help protect Australia's aluminium industry from supply chain disruption and increase our manufacturing resilience and capability. In the Alcore project, the increase in security of supply for Australian aluminium smelters of aluminium fluoride from the smelter bath is also an excellent illustration of the circular economy. The aluminium industry is focused on minimising and reprocessing waste, as enthusiastically looking at solutions that enable excess bath to be able to be reused within the industry. I hope you enjoy your time at Alcore's facility, and I look forward to the continued development of this vital contribution to Australian industry. Thank you.
Okay, so that's a good lead-in to Alcore's strategy. So first, I've summarised APX. Margarita's then set the scene that, aluminium is an important industry for Australia. So very big picture here. Can we do something to help the aluminium industry? And now I'll take you through the logic and the strategy for Alcore. Because, in any of these situations, that's actually more important than the technical. There's plenty of technical ideas out there that are good, but they don't happen commercially because the commercial need is not there. So you really have to deeply understand the commercial situation before embarking on a new technology development. So very simply, in case you're not aware, the aluminium value chain, you mine bauxite, you then refine it into alumina, which is basically bauxite. You take out the iron oxide and silica and titania, you're left with pure alumina, aluminium oxide. And then there's a smelter, which basically means putting a huge amount of electricity through alumina, and you split it into aluminium and CO2. So often in Australia we think, we're a mining country. Actually, aluminium, we're one of the relatively few countries that has big industries, bauxite mining, alumina refining, aluminium smelting, and then even the downstream, which is when you extrude aluminium into window frames and sheet for cars, etc. So it's a very important industry in Australia. You can see on the map there where the activities are around the country. It's also important regionally. Most of the employment is in regional areas, makes it even more important. And you can see on the scale, on the table at the bottom, we're the number one producer of bauxite, right up there. We're sort of equal first with Guinea and China. We're still number 2 in alumina, behind China. We're number 7 on aluminium. We used to be higher. I think 30 years ago we were probably 4th or so. There's actually an opportunity to increase that again with our renewable energy resources. It's possible we could get back up the ladder on aluminium production. So recognising that, and the Aluminium Council, led by Margie, has been very important on this, and people might have realised the whole discussion about minerals and metals in Australia has changed, I think, in the last 5 years. Certainly changed, and I've been in the industry 25 years. For the first 20 years, it was about survival in terms of, okay, fine, we're good at mining, but if you're talking about any sort of downstream processing, it was about survival. Even the Department of Industry, their basic policy was, how do we close our aluminium smelters and steelworks in a steady schedule, not all at the same time? That's completely changed in the last 5 years. I think triggered by a couple of things. One, the renewable economy, and we need actually a lot more metals to transition to electric vehicles, etc. Two, things like COVID and geopolitical tension have shown you can't just assume you'll be able to buy whatever you need from around the world. You need local capacity and capability. And there's a lot of value in downstream and a lot of jobs. There's, for every job in bauxite mining, to turn that into alumina or aluminium, it's like 10 or 20 times as many jobs. So as part of that, the Australian Aluminium Council, we campaign heavily with the government to recognise the importance of aluminium. And as Margie mentioned in her video, aluminium's been added to a new list that the government's called the Strategic Materials List. So they have a critical materials list, which is things, typically newer metals where the markets are very immature, things like rare earths and lithium, fluorine's just been added. The Strategic Materials List is for the, bigger markets that are still need industry assistance of some form or industry policy. So that's aluminium, copper, tin, and a couple of others. And so we're quite active now engaging with the government. So late last year, I was part of an Australian Aluminium Council delegation where we met with a whole lot of ministers and advisors at Parliament House and gave them a briefing on the aluminium industry. And so I got to talk for a few minutes about Alcore and how we fit within that. So definitely the government has a much better, I think, understanding of the importance of minerals and metals and what type of assistance is needed to help Australia continue to be a leader in those industries. Okay, so now we drill down again to fluorine. No one's ever heard of fluorine, maybe, apart from your toothpaste and your drinking water. But fluorine is actually used in a wide variety of industries, and Chris will talk about that later today. So the fluorine value chain, you start with fluorite, so that's an ore, mainly calcium fluoride. You mine that and you turn that into fluorspar. It's a bit the equivalent of alumina, it's sort of pure calcium fluoride. And then it's mostly converted into hydrogen fluoride, which then has a number of applications, one of which is aluminium fluoride, used in aluminium smelting, but other applications such as fluorochemicals, Teflon, purifying graphite, etc. Unfortunately, Australia's involvement in this value chain is pretty small, i.e. zero, and we don't mine fluorspar. I've got a zero question mark at the bottom. I don't think we do anything with fluorine whatsoever. So actually, as I said, originally when Alcore had the idea, hey, let's process bauxite into aluminium fluorine, the problem was the fluorine. We would have to import it. Alcore would have to import it, and that is just prohibitive. And so in recognition of the importance of, all countries recognise the importance of fluorine. Fluorspar is already listed as a critical material by USA, Europe, China as well, even though it's not listed. And even Australia added it as a critical mineral late last year. So everyone recognises fluorine's important. Okay. What's the situation with, we've got aluminium as an important industry, fluorine's a critical mineral that has one application in the aluminium industry. How does that all work? So the aluminium industry, to make aluminium metal, as I said, you put a whole lot of electricity through alumina, and you need a fluoride electrolyte. It's basically the liquid that holds the alumina, and it's the only thing that dissolves alumina is a complicated fluorine chemical. So for an aluminium smelter to run, it needs to keep adding some aluminium fluoride to make the smelter stable. And that market, because the aluminium market is so big, even the market for aluminium fluoride, which is an additive, is still over US $1.5 billion a year. Basically, the aluminium industry world is self-sufficient. So China, for example, produces half the world's aluminium metal. It also produces half the world's aluminium fluoride to supply its smelters. Likewise, there's an aluminium fluoride plant in the Middle East that supplies the smelters there, and one in a couple in Europe, etc. Australia, I already said, still number 7 in global aluminium production. We are the largest region where we don't make our own aluminium fluoride. So here we've got an industry where we've said we're one of the few countries that does the whole value chain, yet there's a critical raw material where you can't run a smelter without it. Literally, within a week, your smelter would be in trouble, and we rely totally on imports. Now, we can't predict, is COVID going to happen or something else? But something can happen. There could be a reason why aluminium fluoride can't get here. It is very risky to have such a large industry and so many jobs dependent on importing something. And it's a pretty expensive material, so over US $1,000 a tonne, because fluorspar is actually a pretty rare mineral, or it's pretty rare to find a good quality deposit. So, we know we want to produce aluminium fluoride here. We know the industry needs it, but fluorine's hard to get and it's expensive, and Australia doesn't make any. What are we going to do? Well, what we recognised from our engagement with the aluminium industry was that the industry is starting to produce more of a waste material that contains a lot of fluorine. So what it's called, the material is called aluminium smelter bath. Ironically, it's actually that liquid that is used in the process to dissolve alumina. The way the process works is eventually it actually produces a surplus. For decades, everyone's been happy because a typical smelter would produce a surplus, but new smelters needed an inventory of that material to start operations. So there was a happy balance. Lots of smelters producing a small surplus, new smelters being built would buy that, and everyone's happy. The problem is, and it's really changed in the last 5 years, there's very few smelters being built now. So in China, they've built a huge amount of capacity up to 2020. They don't need to build any more smelters. So now all the smelters around the world, ironically, including China, are saying, we're still producing this surplus, but where's it going to go? So the global market's moved into oversupply. It's a hazardous material. It's 50% fluorine. You can't just throw it in a landfill hole. What are we going to do with it? So it's very appealing as a low-cost source of fluorine. So we're saying we want to make aluminium fluoride here in Australia. Here's a waste, ironically from the same industry, full of fluorine. Can we close that loop? So that's exactly what we've done. So we've developed a process to reprocess the aluminium smelter bath into hydrogen fluoride. And so Alcore is an 83% owned subsidiary of ABX, and that hydrogen fluoride, as I said earlier, can be converted into a number of chemicals and applications. Aluminium fluoride is a significant one. I think it's about 1/3 of the world's hydrogen fluoride is converted to aluminium fluoride, but hydrogen fluoride has a number of applications as well. But fundamentally, our process is a low-cost, environmentally friendly way of producing hydrogen fluoride from a waste. So this is really I call it exemplary, I think it is, the exemplary application of the circular economy. We're taking a waste and ultimately turning it back into a chemical that the same industry can use. That's just perfect. Just to show the flow sheet in a little more detail, so the top section is what Alcore is doing, It's taking that smelter bath, it's reacting it with a special form of sulfuric acid, and you make hydrogen fluoride, and you make, which comes out as a gas, and you make some metal sulfates, which are a solid. There's a couple of options for that material. One is we may be able to sell it directly, and there's that potential applications for that mixed metal sulfate material. We also have already done work to show that we can separate them into a couple of different sulfates, say aluminium sulfate and sodium sulfate, and there's definitely markets for those materials. The second step of the process is the bottom half, where you take that hydrogen fluoride, react it with alumina trihydrate. It's basically a form of alumina, and you make aluminium fluoride and water. Now that is an existing commercial process. We don't need to invent it, but it will be part of our plant in Australia. So in Australia, if you had a plant to convert aluminium smelter bath into hydrogen fluoride, actually that'd be so much hydrogen fluoride, there's not a market for it here. So we will convert most of the hydrogen fluoride into aluminium fluoride, because that's what the demand in Australia is. We've got a big aluminium industry. So, okay, good idea in theory, right? We've got a need for fluorine. We've got an idea to get fluorine out of a waste. But, is the industry interested in it? Is our hypothesis about the opportunity and the challenges correct? So the thing you do in this situation is you talk to everybody. So we talk to aluminium companies all over the world. Yes, basically they all agree and say the same story. We've got a problem with this excess bath. We increasingly don't know what to do with it. A lot of them are stockpiling it. So we're very interested in ways to reprocess that material into valuable chemicals. And then the extra dimension in Australia is the smelters here say yes to those problems, but also yes, we have a problem that we have to import our aluminium fluoride. So hey, Alcore, if you can convert the bath into hydrogen fluoride and then aluminium fluoride, and we can buy it from here, so if we can buy the same stuff that we need and it's the same price or lower than what we pay now, and it's from a waste and it's locally supplied, we love the idea. So smelters both here and overseas have been very forthcoming with assistance in terms of samples and discussions and commercial information. The obvious question then is, well, if you really care about it, will you invest with us? It's been a big focus of ours. We haven't managed to secure it yet, but there are very active discussions happening still now about that. I do believe at some point, definitely, we will get investment, but we don't have it yet. And then it's not just the hydrogen fluoride and the aluminium fluoride. The process produces other products as well. So again, we've been talking to multiple different customers in different industries about our sulfate products to make sure that, one, there's a theoretical market for the material. Two, understanding, well, what actually is the specification that we have to produce, how many tonnes, etc., etc. So I want to emphasise the point. Again, I don't spend too much time on this business on the technical side. That's really Shao and the team. I spend most of the time on the commercial and the strategy side. That's probably actually the bigger risk. Well, not the bigger risk, but in general terms, in new process development, people often fail more on the commercial side than they do on the technical side. We're making sure we're not going to do that. And so the way I summarise this to interested parties, I've been doing new process development for 25 years. Very common, you got an idea, and you go, great, this will be 20% cheaper than the existing process. And you start working on it and you realise, but actually the product quality will be slightly different and we'll have to convince the customer to buy this instead of something else. So often there's a red flag somewhere that kills your idea. Completely different to the reason that you started working on it in the first place. This opportunity is a really rare one that is financially, strategically, and environmentally attractive. There's no negative on it. All right? We've got some clear positives. Should be cheaper. We're using a waste, and there's no negative. It's a very advantageous position to be in. And just to really highlight that, the graph here on this page, so the column on the left is sort of an illustrative cost of making aluminium fluoride today. And what I've highlighted there is that the floor spar is 40% of that cost. So floor spar can be over $500 a tonne. Other materials are sort of about 30%, and then there's some other costs, utilities and people, etc. But it's mostly materials and it's mostly floor spar. So if we can largely develop it's a similar but different process. We replace the floor spar with the aluminium smelter bath. If you can access that aluminium smelter bath at a low cost, to waste, certainly the evidence is we can get it at low cost, and you keep your other costs the same, your other raw material costs and your utilities and labour, your total cost comes down a lot. It's, again, a really simple commercial opportunity. We're not trying to invent a new product. We're not trying to convince somebody to buy something they didn't know they needed yet. It's going to be the same white powder they buy now, but it should be cheaper because the key raw material is cheaper, and it's coming from a waste. It's a very easy story to tell a potential customer and very easy to get their interest and commitment to it. The other ironic thing about it, often, and I've seen this a lot in my earlier career, we have a lot of waste in the world now, and it's pretty common for someone to go, I've got access to this waste and it's got heaps of magnesium in it or something. It's going to be a really cheap way to make magnesium. But actually the material, the waste, is diabolical. It's a mess. It's got all sorts of stuff in it. There's a reason it's a waste. It's the result of going through a whole chemical plant. So you might say in theory there's something valuable in it, but actually it's really hard to get it out. This aluminium smelter bath, ironically, is actually a very good quality material. As I said, it's actually the liquid that's used in the process to dissolve the alumina. Smelters have spent an inordinate amount of effort. I've been involved in it, trying to make this a really good quality material. It's actually a better quality material than fluorspar. So when you're trying to use it, or we're using it to make hydrogen fluoride, it actually is, in terms of impurities, it's actually easier than it would be to use ore out of the ground. There's less impurities in it. So again, it just reinforces the simplicity of the opportunity. Can we replace fluorspar with a waste? It's good quality material and make the same product at the same or lower cost, and can we do it in Australia? And so that means when you run, I've got a big spreadsheet with lots of different scenarios on it. The good thing, because of that fundamental advantage of using the cheaper raw material, even if you be pretty conservative on economic assumptions, so, okay, what's the price of aluminium fluoride? How much will the bath cost? How much will the sulfuric acid cost? And what's the exchange rate? It's still nicely profitable. And if you be a bit more optimistic with parameters, a bit higher aluminium fluoride price, a bit more favourable exchange rate, it looks even better. And again, that's quite unusual. Often with a new process idea, when you do the range of scenarios, your baseline condition's okay, and in your optimistic scenario is good, but your pessimistic scenario, or even slightly pessimistic scenario, is not good. What we call baseline here is actually pretty pessimistic, and even that is nicely profitable. So again, it's just reinforcing that position that our relative cost position to other hydrogen fluoride and aluminium fluoride producers should be very good. And it just means you can survive the dynamic market conditions that can apply in the world. So how do we do all this we're a small company. The key thing is finding and keeping some good people. And I'll highlight two here. So you'll hear from Xiao Liang shortly, and you'll meet Vishva today, but two very good engineers. So they, along with Steve Holday, are here 100% of the time, working on the technical side of how do we scale up this process. Without them, I tell you, we would be struggling. This is only the third time I've been here this year. I don't need to be here that often. Talking to the team a lot, but fundamentally, they understand the strategic context, the opportunity we've got, but they are doing the day-to-day thinking of how do we make this technology work. It's pretty hard. It's hard to find good people. It's not too hard to find people. You can find some engineers around, but to find really good ones is hard, and we've done it. So I'm just going to summarise the scale up here. Xiao will talk a lot more about the technical side, and I'll come back to this at the end of today to bring it together. What's our plans for Alcore? But just to summarise so you can see it in your head, when you've got a new process idea like this, scale up is critically important. You cannot, I guess you could just go to a bank and say, please loan me $200 million and I want to build this plant. They won't loan it to you, but if they did, you'd probably blow it all because the plant won't work. There's just too many uncertainties. So you have to do a very measured, but at the same time, as fast as you can, scale up process. And that's basically to de-risk it. It's not about, you don't necessarily have to prove it at each stage, but you have to be very clear to say, what are we not sure about at the commercial scale, and what do we need to investigate at a smaller scale to reduce or eliminate that risk? And so those 5 boxes across the bottom summarise our scale-up plan. Initially, we did a lot of laboratory work here in the lab just next door. We've now moved on to we call the batch pilot plant, which we've done plenty of announcements on that, and what you'll see later this afternoon. It's in the back section of the factory. The next stage is planned to be a continuous pilot plant. So that requires a footprint, basically the size of this entire room we're in here. That could be done here on this site. That was the original plan. We actually now have potential option to do it at another better site. That's dependent on some discussions with potential strategic investors. And then our commercial plan is to initially put what we call a stage 1 commercial plant in Tasmania. And that's designed, again, basically as a stepping stone to the large commercial plant. At the moment, we've judged that it's too big a scale-up factor of 150 times to go from the continuous pilot plant to the stage 2 plant. So we're being conservative at this point to say we need a stage 1 plant in between. That stage 1 and 2 plant will both be, at the moment, planned to be in Tasmania, in a major heavy industry area. We've had discussions about potential sites. The government and the companies and everyone that own the land there are very receptive. And then, aluminium is a global industry, so we're not just about doing it here. We then could build plants overseas in other major aluminium producing regions. There are definitely parties we talk to that are, keen. They're saying, look, when have you piloted the technology? We want to talk about how big a plant we could build here near our smelters. And then lastly, as Chris will talk a bit more about today, I mentioned earlier, HF, hydrogen fluoride, is not just used for aluminium fluoride, it's used for a number of other applications. In Australia, we've been quite limited in these because we haven't produced hydrogen fluoride for a long time. It's prohibitive to import. When Alcore is up and running, producing hydrogen fluoride at a good price here, that can be an enabler and a catalyst for a wider fluorochemical industry in Australia as well.